No, super excited to be doing this. We've been meaning to do this for a while. So just as a means of a quick intro, my name's Jenn. This is Paul. We're the co-founders of Open Source Malware. And we're going to be doing this hopefully on a regular basis, weekly basis, where we spend a few minutes breaking down some recent news in the malicious open source world, and then pivoting to talk about something that we've been, observing in the industry, best practices, things like that. So let's start with Bitwarden. Paul, when I got up this morning, for context, I'm in Pacific time. Paul's in Australia. I saw Paul had been busy overnight, as had other people in the industry. Bitwarden CLI was compromised. There was a malicious version published, version 2026.4.0, which has already been taken down. So if you didn't upgrade, you're fine. But it's always possible that it could have gotten cached. So everyone should still know about this, that it's happened. It was discovered by the JFrog research team, and the threat actors self-described this as Shai-Hulud, the third coming. And we're going to circle back to that because we have thoughts. So kind of in brief, what does it do? So it includes two files that are going to steal environment variables and credentials. We're seeing a lot of this lately. So kind of 5 steps to this malware. Number 1, on npm install, the pre-install script is going to run a bw_setup.js file, which silently installs a bun and then executes another JavaScript file. That file is going to run an obfuscator bootstrap, reassemble its string table, and then execute its entry point under bun. Exciting so far, right? No, so the exciting part is it's harvesting credentials from any developer workstation that it's installed on, as well as CI runners. It's validating and escalating across several types of environments. So AWS, GCP, Azure, GitHub, and then it's exfiltrating. So let's see here. Before we talk about what we think about this attack, how bad is it, et cetera, let's take a quick peek at our threat feed for it. So Paul, why don't you talk the folks through what they're looking at? And I'll share this link in the comments so that anybody who wants to take a look at it can. This is ungated. I happen to be logged in with a pro account, so I can see more data than other people.
Yeah, so I mean, like, listen, this happened last night, so it would have been not quite 12 hours ago, roughly speaking. And the npm package was up. My math says it was up for about 14 hours. I saw somebody posted a link or a screenshot of the downloads, and it showed only a couple hundred downloads of the CLI. But the reality is this npm package is actually very popular. And I think it gets 1.3 million downloads per week. I had it installed. I don't have, auto updates enabled for most npm things, and so I didn't get the bad version of it. But a lot of people use this particular CLI because programmatically, if you want to connect a Bitwarden vault to something, you have to use you got to use this npm package, right? So it's pretty popular. Good attack target. What we're looking at here, hopefully, is the OSM, Open Source Malware threat report for this particular package. Jen's right, it's 2026.4, the version. If we look at the top of the threat report and the threat description, basically this is a single compromised version of an otherwise legitimate package. As I said, I've got it installed, or had it installed, and no longer. But it was compromised by we think Team PCP, which kind of vibes. I was just looking before we went live. Doesn't look like Team PCP has taken official. They haven't said that it's them, but it does kind of vibe with what they do. But basically, it's a Trojanized version of it. Drops, like Jenn said, 2 new files. So if you diff it against the last version, it's going to have 2 different files, and the package.json will be different because it'll call that lifecycle script, which it doesn't typically. And then those 2 scripts, as Jenn pointed out, kind of bring you onwards to glory. I think or bad glory. Not good glory.
Glory is a debatable word, but sure.
Yeah. Glory for a threat actor, douchebags that they may be. So listen, hey, what they do, what the payload does is that actually, and this is where it starts to vibe with Team PCP, is actually a cloud native infostealer. So the first thing it does, which is really unique, is it downloads and installs 4 SDKs: the AWS, the Azure, the GCP, and the GitHub SDKs, so it can then talk to those platforms programmatically via the payload. And it basically goes and does what you think it does for a cloud native infostealer across all 4 of those environments. And it sucks up a bunch of stuff. It also, by the way, Jen, sucks up Claude. We're seeing this now more and more, where infostealers, including DPRK, Invisible Ferret, I think the latest version of Invisible, I could be wrong in this, I think the latest version of Invisible Ferret also hoovers up Claude and other AI config files. But yeah, it's just a kind of cloud native infostealer. It's meant to be run in either a CI environment or on a workstation, a laptop, and we'll just suck up all those credentials and things. If it runs in a CI environment, if it runs on an EC2 instance, it does check metadata to see if it can grab data out of metadata, which is kind of classic AWS and cloud tradecraft. And yeah, it's a fun little payload.
Fun. Let's take a look at the threat graph that we have put together here. So we have Bitwarden. We have this domain audit.checkmarks.cx, and then we have 2 C2 servers. Maybe talk through what these relationships mean.
Yeah. So basically, if you deobfuscate this all the way down, turtles/deobfuscation all the way down. Basically, this exfils out to a lookalike checkmarks domain, checkmarks.cx. And we saw something similar to this when Team PCP. And the other reason that people are attributing this to Team PCP is that they did take credit for the checkmarks kicks attack. And they used similar tradecraft there. Same thing here. It's a lookalike domain. Exfils all that hoovered up cloud stuff to an endpoint in checkmarks.cx and an endpoint called telemetry, which you see this quite common. Bad guys will use kind of telemetry endpoints or fake ones because it looks legit, right?
Yeah, for sure.
And I don't know if I actually haven't looked at this part of the payload enough. But I think that the secondary, I'm going to guess the secondary exfil point is the IP address, but that might just be what checkmarks.cx resolves to. So I haven't verified that.
You know what? We walked through all of that, and I just realized I never added it to the stage. So just in brief, this is what we've been talking about.
I was wondering because I didn't see it.
I know, user error, right? No, definitely it's me. So kind of clicking back over here, what you can do if you come to this page is you can get the threat description that Paul was discussing, all of these payload details. I see since I looked at it this morning, the IOCs have been updated, which is super helpful. If you did ingest this, can help you kind of take a poke around. We have evidence linked, and then this would be the threat graph showing the relationship between Bitwarden CLI package, that sneaky domain, and the C2 servers. So I think what would be interesting. Oh, do you want to?
I was just going to say, I'm literally updating that exact report right now because Tom Abai has done a great, I think that's how you say it. Tom, if I said your last name wrong, I really apologize. But Tom is somebody I've been following for a while. Great researcher. He's done up an amazing analysis of the payload from beginning to end. Well, the whole thing, the whole kill chain from beginning to end. And so I just put that into the external evidence and references section inside the threat report. Sorry, Jen.
No apologies required. That's it's always great to get the fresh stuff. So let's talk about why you don't think that this is the third Shai-Hulud wave, the third coming of Shai-Hulud, as the threat actors have claimed.
Yeah, I mean, I think, hyperbole is, we live in a culture. I mean, Team PCP is like spending a lot of time. Well, they're spending less time on Twitter than they were before. But, I said to them publicly, I mean, not that I'm rooting for the bad guy or anything, but like, you guys are out there talking a lot. That's not good, right? Like, you're just drawing attention to yourselves. You're dropping OPSEC, like maybe don't do that. So this is definitely not Shai-Hulud. I think all the researchers that have looked at this that I trust, don't think this is the original threat actor. One reason for that is the kind of, so basically, if you go and look at the actual commits that the threat actor made in the Bitwarden CLI config in GitHub, it's kind of like they tried multiple times in public commits to try to get the thing to fire off, right? Which means that they weren't staging this. It means that they were doing this in more or less real time, which is fair enough. But if you do something in real time, if you're experimenting in real time, you drop hints, like you expose your thinking, you expose your flaws, you expose your tradecraft. And that's why, the APT nation state threat actors never, almost never do that. So I would say that's part of the reason I don't think it's Shai-Hulud second coming. The third is that the worm was
not very wormy.
No, not very wormy. When I checked last time I checked, 3 people had been wormed. Now that is 3 people, just to be clear. That's 3 people. And I went and looked and they got pwned properly, right? Like their, GitHub credentials and a bunch of other stuff was filled publicly. And that part is similar, Jenn, to Shai-Hulud. Yeah. So basically what happens is not only are these exfil sources, and by the way, I haven't had a chance to kind of really drill into what's getting specifically exfilled there and what isn't. But what I know based on what I saw last night before I went to bed is that this is following the kind of Shai-Hulud style where when they exfil stuff, they drop it into public GitHub repos. And so what it looked like to me is that they were a la Shai-Hulud. They were creating net new repos in the compromised users that had common strings. So the team PCP or whoever it is could go and like find those easily using the API, the GitHub API, the GitHub search, which you could. So that's very similar.
There's a difference between inspiration and the real thing,
100%.
right?
Right, 100%.
All right, let's put a bow on that. I don't think it's like the most fascinating sample for good reasons. This is hopefully not a wide impact, but I want to talk about a trend that you and I have been observing for a while. I talked about it a bunch last week when I was in Phoenix for VulnCon and in Denver for Snowfrock, and that is npm lifecycle scripts. And so I want to talk a bit about what they are and what you might want to be thoughtful about, because they do open you up to the probability that if an account that you trust, a maintainer you trust, has been compromised, that if you're using these lifecycle scripts, you're a little more likely to install something you weren't expecting. I mean, certainly it can come about in, bad from the core types of malware as well. So here's how I describe these scripts, and you tell me if you like this definition or not. When you're a vendor, you want to make using your thing as easy as possible, right? The easier you make it, the less friction there is, the more likely people are to use it. And so what these lifecycle scripts do is mean that when you do npm install, you don't have to go through and approve each little thing to get installed. And so it can include like a pre-install, a post-install. And what we're seeing is this little convenience factor. Threat actors take advantage of it. They took advantage of it with this Bitwarden thing. They took advantage of it with Axios. I mean, we see it in almost every ATO, and certainly lots of non-ATO situations where they say, we're going to hide this, benign looking file in the package, and it's just going to get auto installed. And that's why we say it's a different, you don't need an attack path with malware. These lifecycle scripts essentially create that attack path from inside the colors in the house. So Paul, what would you say about these scripts?
Oh man, we could spend an hour talking about just these scripts. So listen, npm gets a lot of shit for still having lifecycle scripts, post and pre-install script. There's also something called an install script too as well, but so they get a lot of heat for it. But just to be clear, all of the package managers have had historically something similar and still do. Here's the thing. So, PyPy famously, started they basically the underscore init files, they did some stuff so that those weren't auto running. But the reality is you can still create those weird PhD files or whatever they are. There's other ways to auto start. Oops, hitting my mic. I'm getting so excited. And there's other ways to auto start in Python too as well. And the same thing happens across the board. And the reason why is, let's just be clear, packages are not libraries all the time, right? In other words, they're not meant to be imported. Sometimes they are, right? But a lot of times, especially with npm, you're building CLI tools, and these are tools that you're going to like piping stuff in and out of. You're going to be using them, and so you need that. It just runs in a different way. So what we're doing is we're expecting two totally different use cases to like kind of follow the same instantiation mechanics, and we just can't do that. So as much as a couple other things, as much as I would love to see the pre and post install scripts go away, I like them being there because it's easy for me to detect, and everybody else that's scanning, the first thing we look for is post and pre-install scripts. And all the low end threat actors and even some of the high end threat actors still use them, and so that makes it relatively easy for us to find them. B, the reality is that having written a lot of JavaScript CLI tools, the post and pre-install scripts come in handy, but then there's also other things you can do. Like there's, for example, npm supports this bin component which you use for CLI tools, which basically creates a symlink in your and sources the path the right way. So it takes a JavaScript .js file and makes it look like it's a binary and runs in your path is its path for its local instantiation is exported to your path variable, and so you can use it. Those are really, really different use cases, and we have to understand that's why these things still exist. Do they cause us pain? Yes. Are they easy to detect? Also yes. So it's a more complex, and it's just like everything else. It's like we were talking about earlier in our chat, this pin versus like pin
version
versus
pinning, cooldown periods. There's a myriad of things that you can do to like add some friction for the threat actors. Some of those things are easier than others. So like you look at pnpm, you look at bun, you look at other ecosystems where these lifecycle scripts are off by default and you have to opt into them. What's different about npm is it's on by default, and people are using these without realizing what the risk is. And that's where we have some opportunity for change, right?
Yeah, for sure. I mean, I think that the reason they're on by default is because of that earlier use case that I was talking about, right? Like I get why it's still there and why it's still enabled by default. I mean, you can make the same argument about VS Code and tax file, why it was, why it's still so easy to enable those things. But you're right. I would also say, just to double down on this, that if you're a developer and you're developing like a true library, pnpm makes some sense, right? But if you want to build a CLI tool in JavaScript, you're going to go to npm, and that's just the difference between the use cases. So
I dug up a resource this morning. Let me find the right tab. OWASP, which I know you and I are very familiar with them, but not everybody watching might be. OWASP, I always forget what it stands for, is essentially the Organization for Application Security. And I'm going to leave it at that because what it stands for is less important than what it is and does. So OWASP has published this, they're calling it a cheat sheet of npm security best practices.
Oh boy.
Oh boy.
I haven't seen this.
Yeah, I hadn't either. I haven't even looked to see like when it was published, but maybe we can. There's probably 10.
Can I
had
live
to hazard
roast?
a guess. Oh no, there's 11. Look at that. 12. Okay, they broke their normal top 10 list. I love it. I think there's some very obvious stuff in here about, avoid publishing secrets to the npm repository. Enough said about that. Enforcing lock files. Right here is where they kind of talk a bit about minimizing the attack surface by ignoring run scripts. And they talk about using an allow list for lifecycle scripts. So I'm not going to make you have a hot take on this document because I know
I've just seen it for the first time.
and that's unfair. But I will go ahead and share the link in the comments so that anybody who wants to take a look at it and see, what value there might be can do that.
I mean, there's good stuff here, Jen. I'm only 5 in of the 11, so there's good stuff here, but I mean, none of it is groundbreaking.
But here's the deal: it's not groundbreaking, but you and I go to a lot of conferences and talk to a lot of people, and a lot of these things aren't happening.
Yeah, 10-4. I mean, the whole thing, number 6 or whatever, the artifact governance and supply chain protection. So they're basically saying that, use some sort of proxy. Either it's something that you build yourself or you use a local npm proxy, or you use something like Artifactory or some other kind of place to store your packages. The reason that breaks down in a lot of organizations, just to be clear, is because you implement this and then developers start complaining and saying, hey, listen, I need this new library, this new version, and it's not in Artifactory or whatever. And then some team that doesn't really understand how a software sausage is made takes 2 weeks or 3 weeks or 6 weeks to okay it, and then it finally gets added, and that just breaks the ability to build and write applications quickly. And so,
well, one of two things happen in that circumstance. Number one, it slows down, or number two, they find a way around it, whether an approved way around it or an unapproved way around it, and correct. The outcome is the same. You make your security processes too hard to use or not well aligned with software development, and they're in the way. Now, what I'll say is it's been interesting. I'm hearing more and more people talking about doing private registries and wanting to see private registries. So yeah, it will be interesting over the next year to see how many people are increasing that adoption.
Yeah, agreed. Continuing to look at this list, number 7, responsibly disclose security vulnerabilities. Now, I haven't read the blurbs underneath it. I don't know if they're aiming this at people outside of the maintainer group or if they're talking about the maintainer group. But the problem I run in, just to be very explicit, is that when I find a vulnerability or I find a malicious package, reaching out to the maintainers often is very difficult. And especially if it's a vulnerability, often you're going to get a lot of pushback. So a lot of these things
they're talking here specifically about security researchers following responsible disclosure, and I would apply exactly what I said about the last thing to this. If you make it too hard to responsibly disclose, then the benefit goes away, right?
And even when you do have a good pipeline, sorry, I interrupted you there. My apologies.
Go for it.
Even when you have a good pipeline, for example, you look at the curl team, Daniel, famously, the most visible, transparent, open source project that accepts and has been doing this for a long time, accepts both bug bounty, submissions and disclosures. They're getting slammed by so much AI shit. Well, and now it's even worse, now it's changed. Daniel says he doesn't really know how it's changed, but now it's not slop. It's mostly not slop anymore. It's good, but the problem is it's just the volume of it. The models, Opus and 4.6 and 4.7 had a lot to do with that too as well. But so I mean, I guess like I said earlier, these are all things that are enable 2FA. NPM now is tackling that, and PyPy
we see
as
tokens
well.
in here, which honestly, this may be a little dated. We'll have to dig into the dates, but
right.
PSA out there, leaked tokens is a leading cause of breaches these days. So if you have an option that's not just a token, go get yourself a hardware key.
Well, and like the problem with RC tokens in particular, right, which is I think what they're talking about here. Let's see, npm token create. Well, okay, so the problem with like 2FA is great and we all should use it where we can, but the problem is when you're deploying the same npm package maybe like 3 or 4 times a day, that 2FA push becomes an obstacle, right? And so you have to create automation, and sure, people should be using things like trusted publishing and between GitHub and npm, but as we saw with today's attack, trusted publishing was enabled, and still the bad guys were able to pwn the Bitwarden CLI. So I mean, again, with a lot of these things, man, it's easy to say them, but it's really fucking hard to do them. And that's always been the problem. Like, why aren't people scanning with pre-commit Git hooks? That technology has been around for 25 or 30 years, but nobody does it because nobody does it.
Yeah I think the other top question I definitely get is like, why do people not do these things? And like you said, it's certainly because it's hard is sometimes the reason. And also I think there's a lot of human psychology behind it. We have biases of like, well, nothing bad has happened, so nothing bad is going to happen kind of things. Right. But we even see with organizations, people who have been popped, that even after that, they don't necessarily enable the things that would prevent it from happening again, or at least decrease the probability. And I mean, yeah, I don't have a great explanation for why that is, other than it's hard. It's hard to do this when it's not your full-time job, and you don't have the resources to dedicate to it.
There's actually 12 things on this list, Jen. The last one,
I know.
12.
I love that it's an OWASP page that's not a top 10.
The top 10.
So I will say a couple of these things are like, you should know this thing exists, rather than a genuine thing you can do, because they are talking about typo squatting and slop squatting, dependency confusion attacks. Worth digging into more. Looks like a reasonably good resource.
Yeah, and just because I have some observations about the obviousness of some of these things doesn't mean I think this is a bad document. I'm glad they had it. I wish I had known about it before today. But I just want to double click on prevent dependency confusion attacks. Dependency confusion attacks happen because people create internal private packages, right? Which they should be doing, right? Which is a good thing. And because of the way the package managers are built, that if you if you come up with a public version of something and somebody hasn't taken the steps to kind of protect themselves from that, they will get the public version of that. And we've known about dependency confusion for years, even before old mate what was his name, him and the guy from Critical Thinking, anyhow, before they made it famous in 2020 or 2021, people have been doing dependency confusion for years, and the package managers haven't really done anything about it because that's just the way it works. So a lot of this is just kind of the built-in, what's the word? I'm tired, so I'm not thinking the word. The lethargy. That's funny because I have lethargy.
Yeah, that's what popped out.
The lethargy inside of the package ecosystems, to do real fundamental changes around things that actually affect developers' use of their tools. But That's what it comes down to. Dependency confusion exists in npm because you can make private packages either inside of npm or other places. And if you call that name of that thing and there's a public version of it, you're probably going to get the public version of it before the private version. And that's something that we need to address at some point.
Yeah, something that I think you're calling out without saying it, and sorry if I'm putting words in your mouth here, is I think there's a misconception that dependency confusion, typo squatting is like obvious.
Right.
And you're a dum-dum if you consume it. Am I picking up on what you're laying down?
Oh my God. I've said the same thing from stage a couple of times, like 100%, especially with typo squatting. You're right. People think about
like, oh, you didn't see that was a 0 instead of an O. And it's like, well, you have to understand, first of all, we can all get pwned by social engineering. I mean, the stuff that people are doing these days is gross and sophisticated. And anyone can click something in an email. But that's not what we're actually talking about here. So with like typo squatting, dependency confusion, this is more relying on like machine automation in some cases. Like you may not be explicitly
100%
reading through this and picking it.
100%. Oh my God, I could say so much about this. Typo squatting in particular, people look down and like, oh, you're such a dummy. Who would be the idiot that would, put a 0 instead of a O, or, would use a I instead of a Y, or whatever the case may be. What idiot does that? But typo squatting is so much more effective. And by the way, everybody talks about these big high impact things like Bitwarden and, chalk and debug and, all the singularity stuff and the Shai-Hulud stuff. But the reality is that every day, if you look at the volume of malicious packages that are hitting npm and PyPy in particular, the vast majority of them are typo squatting and dependency confusion attacks. And they're effective for a number of reasons. And for people to like look down on organizations that get pwned via these is really kind of frustrating because they don't understand how the software sausage is made. The most famous example that I use is that, and you and I have talked about this before, that Web3 parser. So there's a famous npm package and it's only a few years old, or at the time that it was pwned, it was only a few years old. So it was new. It hadn't been around for years, like chalk and debug and Lodash and all these other things. But it was new and it was named Web3. But what it did is it parsed Web3 events and then sent them wherever you wanted those things to go, right? So the bad guys just created a package called Web3 parser, and then they artificially inflated the download stats, which by the way you can still do, thanks npm, and a bunch of other things. They actually made that package look very legitimate, right?
Yeah.
It's one of the best.
Well, and they made it do what it said that it did, and that's the most I think a lot of people don't understand. A lot of these packages actually do what they say they're going to do.
And they don't use post or pre-install. They don't use lifecycle scripts, right? So like Web3 parser is a great example of that. It actually parsed Web3 events. And if nothing else, you're using it, you install it and you import it and you start using it as part of your application, and it's doing what you think it is. So there's nothing there to make you think that it's doing something bad. In the meantime, it's silently, exfilling all your Web3 events to the bad guy as well. But like they took advantage of the fact that the name of the GitHub repo was Web3 parser, and the name of the package was Web3, and somewhere else they called it Web3.parser. So there was within their ecosystem,
taking advantage of the original package not having the best naming, and then they picked a better name. Before we wrap up, I want to have us talk briefly about a couple packages that you came across 2 days ago that we saw were targeting a specific company, because I think it helps tell a story of what we're talking about. And we're not going to name the company. They're aware. We talked with them. They know what happened. But talk about what you found.
Yeah, I didn't know that Jenn was going to bring this up, but I'm really glad you did, because this is super timely. The bad guys this week targeted a particular company, an individual single company inside of an ecosystem, and we'll leave both of those kind of up to, or we won't talk about it, but like the reality is the attacks were successful, or not, weren't successful, but could have been successful because they actually used multiple ecosystems. So they built packages, malicious packages in multiple ecosystem targeting the same users and the same company, right? And that's, just to be clear, they were not targeting the company, they were targeting people that were going to use this technology, blah blah. So and we didn't used to see this. The only time we would ever see multiple packages in different ecosystems it was rare, and it would only be like, Glassworm and a couple of the other really big, well done APT style threats. Well, now with agents and with generative AI and these really, really smart models, it's really easy for one thing. So just to be clear, what Claude won't you do is it won't let you say, hey, Claude, write me up a new infostealer in JavaScript, right? But let's say you get your hands on one and you modify it yourself, and you work with Claude to like find at the function level, make it be successful. Once it's doing its thing and say JavaScript, you can then say, okay, now Claude, rewrite this in Python, or rewrite this in Go, right? Whatever, and it'll do that. So and the guardrails are getting better now. So they're starting to see when there's malicious.
Someone's writing nasty code or asking for nasty code. Yeah.
But you're not asking it explicitly write a payload. Instead, you're saying, hey, can you just take this thing that works right now and put it in this other language, and it will happily do that. And the power of that is just and the immediacy of it makes this. So anyhow, cut to the chase. I think we're going to see a lot more of this happening. All of those packages were deployed within an 8-hour time span across the different ecosystems, right? So they had it all queued up. Now the payloads in this case were in clear text and they weren't super sexy, yada, yada, yada. But, as soon as, bad guys start perfecting this, they'll start obfuscating and hiding it better. And this will be a very successful thing. So I'm glad you called it out.
Yeah. All right. I'm going to share one comment that we got. We have someone on LinkedIn. They're going to steal your software sausage. That's fine, so long as we get the residuals, right? Is that the way that we say that?
Yeah, 10%, mate. 10%.
10%.
I've been saying that for years. The InfoSec doesn't know how the software sausage is made, so I'm glad that somebody likes it.
Yeah. All right. I hope people enjoy this. Leave some comments about what you like about it, what you want to see us talk about. This is probably about the length and format that we'll stick with. Again, we're going to try to do this about once a week, travel schedules allowing. So yeah, Paul, it's been good.
I'll try to be more energetic and
you're great.
have more sleep next time.
All right.
Cool. See y'all.
Yeah.
Ciao.